All right, so we're going to continue on writing about decimals in standard form. Now that's going to take us into some of the concepts we've gone over before. So this is really more of a review of things we've already been doing. So let's jump in right with a warm up. Now, for this warm up, it wants us to use base 10 blocks, but because that's not really practical, like we don't really have a set of these on us at all times, we're going to be able to use a place value chart, which is something we can make really quickly on our own just with a piece of paper. And let's compare these two numbers and then write them in word form. So we have 0.24 and 2.04. Now those are, I'm not saying them properly on purpose, but we're going to go over that in the next slide. All right, so the first one, let's write this down, 0.24. Now we remember that um, the least place value, the smallest place value, names our decimal. So our 4 is in the least place value, and that's in hundredths. So we would read this as, I'll just write it down here, 24 hundredths. Yeah, 24 hundredths for that one. So again, the place value is going to help us say it in word form, how to say it properly. But for one like this, which I'll do in a different color, 204. Same digits, got a 2 and a 4 and a 0, but we kind of switched them around. But we're going to say this completely differently. The way you do this is you start with your whole number, which is 2, and then we have a decimal point right here, which we know is the word and. And then we have to talk about the fractional or the decimal point here. And our 4 is again in the hundredths place, 2 and 4 hundredths. But that goes to show that we can have the same digits, but the placement of them gives us completely different numbers with different values for that. So just make sure you're doing that when you're doing your work. Okay, let's jump right into the lesson. So that'll be on page 155. And on page 155, we've got two people that are holding a running race, and we have to compare their times. Abba finishes the race 1 and 16,000 seconds ahead of Nadia. Brienne finishes 2 and 3,500 seconds ahead of Chandra. What decimals represent these measurements? So we're not doing any math as far as we just want to represent these numbers in decimal form. And I'm underlining those right there. So the best way to do that is to create a place value chart for them. And let's do that right down here. Let's draw our line across here. Now I noticed that the only whole number we're dealing with are ones. And there's our decimal point. And the biggest, or the least, or the farthest to the right, we're dealing with is thousands. So we're going to have tenths. We're going to have hundredths. And we're going to have thousands. Okay. So let's start with the first one. We have 1 and, so that's 1 and 16 thousandths. So if it's thousandths, our last digit is going to be in the thousandths place. And we're talking about 16. So it's going to sit like that. We have nothing here in the tenths place, so we know to put a 0 in there to fill in those gaps. Now Brienne is 2 and 3,500 hundredths, so that's 2 and this one is hundredths, so our last digit will go into the hundred spot, and then we put it in like that. So there's our numbers for both Abha and Brienne for that one. All right, let's look at the next page and kind of break that apart a little bit. So model the measurements with mixed numbers in expanded form. Now mixed numbers, as a review, are a mixture of whole numbers and fractions. This is a mixed number. Let's go ahead and put a little note right here that these are mixed numbers. And I'll do the same in my book here. But we will deal with mixed numbers probably in a couple of weeks. when we start talking about fractions. And show the numbers as a whole second and a fraction of a second given for each measurement, and then expand. So the first time was 1 in 16 thousandths. So we have a 16. This is our 1 second, and this is our 16 thousandths. And then we can break down the 16 thousandths into 10 thousandths, 6 thousandths, and even further from 100th to 6 thousandths. Do the same over here on the right. We've got 2 seconds, 2 and 35 hundredths. It's got 100 here, and we got 1,000 over here. And it breaks down in expanded form for that. Moving down, the place value chart. Again, probably find it to be the most easiest. That's why I kind of push that for us. We use a place value chart to write these measurements like we did on the first page. Notice it mentions that 16 thousandths is 10 thousandths and 6 thousandths, or 100th and 6 thousandths. Now 35 hundredths is actually 5 hundredths and 3 tenths, just a combined form of that. So you can do expanded form looking at a place value chart by breaking things down pretty easily there like that. So there's that. In fact, over here on the right, let's do this. This is 100th plus 6 thousandths. So there's our 100th with our 1 and hundredths, and this is 6 thousandths. Down here, the 35 hundredths is 3 tenths plus 5 hundredths. So if you combine those together, you've got that. Now, if you lined up the decimals and added them, if you remember adding decimals, you would get those numbers for that. So keep that in mind. All right, so we've got that. Now let's look at the notes on the next page. So compare the mixed number and the place value representations of 1 and 16 thousandths. So 1 and 16 thousandths. There's our 1, and there's 16 thousandths. That's our mixed number version. Now it wants to talk about the whole numbers. So this is our whole number. That's our 1 second. And then the 16 thousandths are the fractions of a second. For over here, we put the 1 in the ones place. Place represents seconds. And that's how we did it with that. So let's place. And then let's look at number 2. Compare the expanded form and the place value representation of 1 and 16 thousandths. How does each model show the fractional part of it? So they showed it like this. If you look over to the left, we know that the fractional part was 1 over 100. That 100th plus the 6 in the thousandths place. And then for the place value chart, the 1 in the tenths, no, excuse me, 1 in the hundredths. Six in the thousandths. So again, 2 different ways to represent it. Whichever way is going to look best for you is the one that you go with, but you can do it 2 different ways. Mixed numbers, since decimals and mixed numbers and fractions are all related, or just put in the place value chart. How can you write 1 in 16 thousandths as decimal? Well, we've already been doing that. 1 in 16 thousandths. How do you write 2 in 35 hundredths as decimal? You write it just like that. Explain how you can write the standard form of decimal given in word form. Step 1, write the whole number. Step 2 and equals decimal. And you have more room on your paper in your book than I have on this board, but we'll just make do. And 3 is, the third part is fractional part. So it's 3 steps. There we go. So again, if I'm going too fast on this, just rewind or pause your video for it. All right, cross off 6. We're not doing 6, but we will do 7, 8, and 9. So cross this one off. 7, what decimal represents 10 and 75 hundredths? Show your work. I could do a place value chart, but I'm going to show you mixed number because I'd really like to get us using that language for fractions and mixed numbers sooner rather than later. So to translate this to a mixed number, we have 10. That's our whole number. And then the word and, instead of a decimal in this point, that lets us know we're about to do the fraction part. And we have 75 hundredths. That means 75 out of 100. Then the next step's pretty simple. To translate to a decimal, we got our 10 and 75 hundredths, which means our last digit, least place value digit, should be in the hundredths, and that 5 is in the hundredths pot, so that would be 10.75. For this next one, we will do a place value chart, mostly because we use a lot of different place values for this one. In fact, we use 7. So good practice to help us remember our place values. All right, so a number is written in expanded form. Let's build parentheses around these parts. So 9 times 1,000, that means your 9's in the thousands place. Parentheses around these two. 6 times 1, that means a 6 is in your 1 spot. 3 and 1/10, that means your 3 is in the 10th spot. And 8 in the thousands, that 8 is in the thousands place. So let's do this. Here's our thousands place. Here's our 100 place. Here's our 10. And here's our 1. And we know between the whole numbers and our fractional parts is a decimal point. And then we've got tenths, we've got hundredths, and we've got thousands. So that represents everything on that. In fact, let me kind of fix this on here. So what we're going to do is we're going to basically put in the numbers that we have shown up here. Now we did a IXL like this already, and I think we did pretty well with it once we got the hang of it. So let's put in what we know. We know 9's in the thousands. We know 6 is in the ones. We'll put our decimal here. We see a 3 is in the tenths, and we see an 8 is in the thousands. What we don't see are these other place values that weren't shown up here in the expanded form. So we just put in zeros here to fill in the gaps, and our final answer is 9,006 and 308 thousandths. All right, one more question. This one's multiple choice, so this will be quick. And we can bring together all the things we've learned so far. Which decimal represents 6 and 44 thousandths? Well, I know this is 6 and then we have 44 here, but this 4 needs to be in the thousandths place. So I need to put a 0 here to bump that 4 over to that spot. And whoop, 54. That's why I wasn't seeing my answer over there. So that 54 rests there. The 4 is in the thousands, and that gives us the answer of C. All right, your IXL homework for today, or classwork, if you're here in class, G2, model decimals, and fractions. You may go to 100% for a house point.